I'm going to show how I use a multimeter and a straight edge to take precision measurements from a guitar neck. I take these measurements to establish the condition of the neck. Is it warped? Is it straight? Does it have an S curve? And then most importantly, how extreme is that curve? The traditional methods of taking these measurements have a fundamental flaw. Basically, you're trying to measure a gap between the fret and the string, but the problem is that string is flexible, it moves. So you can't be sure whether you're measuring the gap that was already there or whether you're measuring the gap that you're creating by jamming something between the string and the fret. So step one is we lay a straight edge on top of the frets. We want it to be vertical. And so we just need something to kind of hold it in place. And I just use one of these binder clips. And I just want to be sure that the binder clip is not actually lifting the straight edge up. And because the fretboard has a radius, I want to be sure that I'm running right down the middle, that I'm parallel with the neck. I'm not at an angle, because if I am, everything I do will be garbage. And the next step is to connect the multimeter to the straight edge. And the way the multimeter works is we're just in conductivity mode, which is the when we do something like this, the multimeter is either going to give me a kind of yes or no answer, that it's either we're making a circuit, we have conductivity, or we don't. And I'm hearing a chime. I think you'll be able to see the screen kind of light up. Again, I don't care what the reading is. It's just yes or no. So the next step is I'm going to find the two most extreme frets that are contacting the straight edge. There will be at least two. There may be more. What I want them to be, ideally, they're going to be kind of as far spread out as possible. In a perfect world, it would be the first and the last fret. So let's try. So the first one touches. That's good. No, no. I'll let you know when I get one that does touch. So right here, that's fret 20. And we have nothing at the last fret. Okay, so that's overall, that's good. First of all, it's great that we only had two frets that are touching. It makes things fairly less complicated. And it's also good that they are at or near the extreme ends of the fretboard. So wonderful. Next thing, I'm just going to get this out of the way for a moment. We need to kind of very, very gently clamp the straight edge down at one of the fulcrum points. And I'm just using this popsicle stick with a little slot in it and a pair of rubber bands. And I'm just going to move it so it's just to the right of fret 1, because I want to make sure that I'm kind of holding it down and not tipping it up like this. And I need to go back, make sure I'm back on right over those dots as parallel as possible, and then reconnect the straight edge. And then I'll just do a quick run through one more time to make sure there's no kind of funny business, no surprises. So yeah, we've got our connectivity in fret 1 as expected. Nothing here as expected, as we had before. And we're back at fret 20, pinging. And now it's showing that we have connectivity at fret 24 that we didn't have before, but no big deal. Just there's something, probably less than a thousandth of an inch that was ever so slightly different from now versus when we had the clip on. So that's great. Now we can proceed with the test. So the idea is I'm going to go ahead, and what happens next, it's pretty much the same as the traditional method where I'm just using a feeler gauge to measure the gap. But instead of measuring from the fret to the string, I'm measuring from the fret to the straight edge. And now I have this mechanism that's going to tell me with absolute certainty whether I have lifted that straight edge up. So we just need to find one of our extreme contact points. It could be either one since they're so close. I'm just going to use this piece of foil that's on a piece of blue tape and connect it to the multimeter lead. And keep in mind the other lead is connected to the straight edge. And I'll go for that last fret. Nothing wrong with that. And actually, so it's kind of going in and out on me. I'm not sure what to say with that. There we go. I just had to give it another squeeze there. Now it's chiming incessantly for me, so I'm going to turn it off the chime mode. And basically now I can just go from fret to fret, and I'll have to kind of watch the screen like you are. And the idea here is that this is kind of like a go no go gauge. I have 2,000 shim and a 5,000 shim. The idea is if I cannot pass the 2,000 shim, that's wonderful. It means the gap is less than 2,000ths of an inch. And in my mind, that's I can round that to 0. It's close enough. I don't think you can tell the difference between a 1,000th gap and a 0 gap. Um, if the 2 can pass, but the 5 cannot, that means the gap is somewhere between 2 and 5. That's not great, not terrible. If you can correct that, wonderful, do that. If you can't, that's a gap, a discrepancy you can kind of live with in terms of playing. Once you go over 5,000ths of an inch gap, that's where you get into some serious problems. They're going to give you buzzing or whatnot. So I'm just going to go fret by fret. Now here, right away on fret 3, I am able to get to 2000 shim, and I feel a little bit of drag, but because I still see conductivity here, I know that I'm not lifting the straight edge. So I know that's a legitimate gap, and I can already tell based on the drag that I'm not going to be able to get to 5 under. And sure enough, I can't. So I know that gap is probably 3,000ths. If I can get the 2 under and I feel a little bit of drag. Um, so that was fret 3, and then fret 4, I'm not able to get the 2000 shim under. So we have ever so slightly, we have a low fret here, fret 3. So moving on, I am able to get the 2 under the 2000 shim under the number 5 fret, not the 5,000 shim. So that's good. I am able to get it under the 6th fret, not the 5,000 shim. So that's a no, no. And we were looking good. So basically, in its resting state, this neck has ever so slight amount of relief right in the fret 5 to fret 7 zone, which is more or less where you want it. And that's it. That's what it looks like. Of course, if you're dealing with a problem neck, you're going to kind of dig deeper and pull out the other your other shim gauges and take more detailed measurements. But that's the gist of it. Thanks for watching.